Hello everyone. Today I decided to post a little video about my progress on setting up the AC servo drives. In front of you on the breadboard is the earlier version of my circuit to operate the motor brake on Z-axis. Over here we see the schematic of that circuit, and it consists of optocoupler that's inside the servo drive. It's routed through pins 28 and 29 of the I/O connector. It's powered by 24 volt. It has a motor brake. As a switch, I use the tip 31 transistor. At the start above the AC servo drive, the signal goes to the optocoupler, and it lights up the LED and opens up this Darlington transistor, which in turn sends the current to the base of the switch transistor tip 31. And when it opens, it activates the motor brake. So this particular circuit and this particular transistor put us at the disadvantage of losing power across the transistor. So we measure about 20 volt on motor brake with 24 volt power supply. That puts us about at 4 volt voltage drop across the collector emitter junction of the transistor, which accounts to be about 2 watts lost on the transistor itself. So I decided to go with the diagram suggested by the manual for the servo drive. It powers the coil of a relay, which activates the motor brake. In parallel with the K1 coil of the relay, we see the diode connected. These diodes, called flyback or shunt diodes, they're connected in reverse to the main current and are only active during the brief period when the power to the coil is disconnected. During this moment, the magnetic field of the coil collapses and induces the reverse current in the circuit, which in our example right now used to light up this LED briefly. Back to our CNC setup. The controller has booted and is ready for operation. We're gonna first move our motors using the MPG wheel. It's a manual controller to fine adjust the position of the machine when needed. And right now we're operating Z motor. There are 2 rotary switches on the MPG controller. One switches the steps per click of the wheel, and the other one switches axes, so we can control each axis individually and separately. Next, we will home the machine by pressing home and start buttons. This will take motors to the 0 position because we don't have end switches right now. Next, we're gonna run motors for a little bit using this file that I saved on the controller's memory, which consists of few lines of G code to move motors to 200 position and back. As we can see, the motors are really moving fast. The speed I set about 3 meters per minute. Next, we're gonna stop and home the machine. The controller takes all motors to 0 position. They all line up keyway up, right where we started from. This is the brake relay circuit, and let's play with it for a few seconds. Digital displays on the servo drives can be used to display various parameters. We're gonna start our program, and the displays will present some numbers. I'm not entirely sure what these numbers mean. They only show some value when the motor is running. It might be the final destination position or the speed in counts per second. I'm not sure. But yeah, there we have it. I want to say big thanks for all of you who watched this video to this moment. If you saw something interesting, hit that like button. Please also share and subscribe for more videos. And good luck to you all.